come and look at these two. This is, of course, a circle, so that should be easy enough to graph and to evaluate. Okay, so it's a circle of radius 2 centered at the origin. So we should be able to get a decent graph of that going. Sorry, it looks more like an ellipse, but that's fine. Okay, and the other is, of course, going to be a polynomial, a fourth degree polynomial, lead-off term being positive, so it's going to look something like that W shape, which we're going to try to map in there. Okay, so let's see. What we have to do is, of course, factor. That expression does factor easily. As a difference of two squares, x squared minus 9 and x squared minus 4. And each of those subsequent factors is x plus 3, x minus 3, and x plus 2, x minus 2. So both of these graphs are nicely symmetric about the y-axis. We're having intercepts here at 2 and negative 2 and 3 and negative 3. And of course our y-intercept all the way up here, 36. Okay, we'll just pretend that's 36 up there. So we're coming down. Again, we had that W shape, so we're coming down, turning around somewhere, coming up. Okay, coming around like that. And I can certainly agree that I'm going to have these 2 points, that is at negative 2, 0, negative 2, 0, yes, and 2, 0. Well, obviously, when they are thrown in there, they yield a 0 in both equations. Okay, you can confirm that with this one. This one should be rather obvious. My question is, and it looks possible, it's conceivable, that from my graph, although it's kind of sloppy, nonetheless, it does give rise to suspicion about another point of intersection there. Okay, and that could be a rather nasty solution method. Okay, so let's just offer some ideas about what to do. Okay, trying to set these equal is going to be rather tough. Okay, because then this is in terms of y. If this was, if this had a y in it, I could actually do it a lot easier. It doesn't. So what I'm going to do is I'm just going to rename x squared as 4 minus y squared. Then I'm going to substitute that back into this, which is going to be y equals x to the 4th, okay, which is x squared squared, so it's 4 minus y squared squared, okay, minus 13x minus 13 times 4 minus y squared, all right, plus 36. Now let's see where that gets me. That's y is equal to 16 minus 8y squared, okay. 13, 4 is 52 minus 52, plus 13y squared, okay, plus 36, yes? Okay, so what happens here? 16 minus 52 is negative 36, and 36, oh good, that cancels out, okay? So now I have 8y squared negative plus 13y squared, so I've got 5y squared, all right? I am mistaken. I have, this is y to the 4th here, I'm sorry, I forgot my line of the fourth term is what happened there. If I can correct that, expand that out. Okay, so that's 16 minus 8y squared plus y to the fourth. Okay, so I do have my y to the fourth term. Okay, I have my minus 5, which is going to be plus 5y squared. Okay, and as I said, my constant terms cancel out rather nicely. Okay, and I'll bring over the y, and I'm going to set that equal to 0. Okay, so now this is a certainly probably not going to be factorable. Okay, but I can take out a y, and when I take out a y, this drops down to a y cubed plus 5y squared. Okay, minus 1 is equal to 0. Okay, which gives me y equals 0. Okay, of course, when y equals 0, I don't concur to have a point of intersection, because when y equals 0, I get two different values, okay, for y equaling 0. In fact, I get no value for y equals 0 here, because it's not defined there, so it's not even worth looking at. So what I have to do is evaluate y cubed plus 5y squared minus 1 equals 0. I know that's a cubic, so cubic always has at least one solution, and I'm actually just going to depend on my calculator to help me find that solution. So let's go to the calculator. That is y cubed plus 5y minus 1. I think I have that up and running here, y cubed. Now, obviously, I can't put that in terms of y cubed, but I'm just temporarily going to put it in terms of x, as you can see right there, and find the intercept. Okay, so we'll graph that and find its intercept. Okay, it's graphed nicely. Finding the intercept is f5 value. So we go to the 0. We go left bound or lower bound, enter, and then right bound, upper bound, enter, and we picked up that the value there is, now again, this is actually the y value of, let's just call it 0.2, okay, let's round it off. Okay, so we have another interception right up here, which actually means we have two interceptions because of the symmetry. So that's at y equals 0.2. Y equals 0.2. Well, if y equals 0.2, what is x? Well, x is, so we just go back into, this would be the easiest equation to evaluate that for. X, of course, is the square root of 4 minus y squared. Okay, so we've got x equals the square root of 4 minus 0.2 squared. Okay, and of course 0.2 squared is going to be 0.04. So that's going to be x is equal to plus or minus the square root of 4 minus 0.04. So we've got x is equal to plus or minus the square root of 3.96. And we kind of, which is just short of 2, obviously, right? Okay, so we have another point of intersection. Okay, it's actually probably visually keeping, okay, is more likely to happen, we said it was at 0.2x and negative, so it's probably more in this line here. So we got those 2 points of intersection. I should say 4 points of intersection. So we had, this is our x value, rather, so our x value is root 3.96, comma, 0.2, and negative root 3.96, okay, comma, negative 0.2, and then the 2 comma 0 and negative 2 comma 0. So this offered us 4 points of intersection. I'm going to tell you what I'm going to do and suggest you do the same, is confirm that by Desmos, okay, and just validate that. I'll be back in just a second after I do that, set that up for you. Okay, I'm back, and just, as you can see, I graphed these two. I want to wrap this up quickly. I know it's getting too long, but of course here's my two functions graphed, and we obviously see we have these points at 2 and negative 2 on the x-axis as points of intersection. But I'm wondering if we can find this other point. Now, obviously, we're going to have to zoom in. To zoom in, we might have to zoom in, pretty tightly. All right, so I'm going to look to find that point that is going to be at that 0.2 value. I think it's right there. It looks like it's highlighted for me right there. Looks like it right there. There it is. There it is. That's that value. Remember, we rounded that off at the y value of 0.2, which is that close, okay? And look at that. So we do pick up that point. We do pick up that point of intersection. It kind of found itself right there for us. And now it's gone, okay? But yep, there it is. There's our point in question, our second point of intersection. Actually, our third and our fourth. So there you go. Got it. 4 points of intersection with those two curves.